All right, hello everyone, and welcome to our fourth session of the Road to the Metaverse Creator Series. Today we're going to discover how to bring your real-time digital twin data into Unity. My name is Drew Demokis, and I'll be your MC for the session. I joined Unity back in 2020 as a creator and developer advocate focused on showing businesses how AR and VR can solve problems and modernize old processes. Now let's meet our hosts. Jerome.
Hello, everyone. I'm Jerome. I'm a senior technical specialist here at Unity. We've been through already a few times, so I'll be brief. I spent about 20 years in digital production and 10 of those working with Unity for visualization, both architectural but also immersive. We did early work with HoloLens and VR. And yeah, I'm here at Unity evangelizing the good word of becoming a creator and helping you get on the journey to create applications for the metaverse. Ben?
Hello, I'm Ben Radcliffe. I'm also a senior technical specialist based out of London, working with Jerome. Again, my background is 20 years in animation, visual effects before joining Unity almost 4 years ago. And I love XR, I love AR, I love metaverse, as you can see. And that's why we're here to join you tonight. Welcome, everyone.
All right, awesome. Thanks, guys. So as everybody can see, we have today's agenda on display here. So following a quick little introduction, we're going to dive into today's main topic. Now, before we get started, if you have any questions at all during the session, please type them into the Q&A pod on Zoom. Questions tend to get a little lost in the chat with everybody posting, so we'll just make sure we can see your questions and try to answer them all accordingly. This session is also going to be recorded, and there's going to be an on-demand version of the webinar made available in just a few weeks. So as always, we're looking to hear from you about how we can improve our presentation. So we have a survey available for today's live session. It's available at the QR code that's on the screen and this link that I'm going to pop in the chat just a second. So here is our survey link. Just to note that this link is only valid for the live session, so a new link will have to be provided for the on-demand version of the session. All right, with that, I'd like to share just a couple metaverse stories and some news. So first up, this was actually announced shortly after our previous session back in June. A number of companies and organizations have formed a standards group for metaverse tech called the Metaverse Standards Forum. And according to a press release, the Metaverse Standards Forum will focus on pragmatic and action-based projects like hackathons and prototyping tools for supporting common standards. It's also interested in developing consistent terminology for the space, where many players can't even agree on what a metaverse is currently. So feel free to check out the Metaverse Standards Forum at the link on screen here, as well as this article from The Verge that I'll post in the chat that goes into greater detail. And I'll just post both of those in the chat right now. There we go. Just a couple extra resources for everybody. And let's just quickly take a look at a use case. So Unity's real-time 3D development platform recently enabled Citywise to create a digital twin of the port of Oulu in Finland. This dynamic and interactive digital twin serves to reduce the environmental impact of transport and logistics flows in the city. So tools specifically designed and engineered for the AEC industry, that's architecture, engineering, and construction, Citywise turned to Unity's real-time 3D development platform to create solutions like Aura, a virtual 3D environment for visualization, data management, and collaboration. This has resulted in increased efficiency up to 15 to 20% using digital data management and visualization. In some cases, the efficiency rate might be even higher. It's enabled cost-effective virtual testing before committing to any high-priced real-world investments. And we've seen reduced environmental impact, improved safety, and more citizen-friendly urban development as a result. So there's a lot more detail on the project, but unfortunately, I only have so much time to get into today. But if you'd like to learn more, there's stories like this and others available at the Metaverse Minute blog post, QR code and link here. And finally, if you haven't already checked them out, we have a dedicated forum for the road to the metaverse. So please check that out, the link in the QR code here to keep the conversation going following today's session. As well, a bunch of resources that will be mentioned today will be made available on the forums as well. And one last time, I'm going to post a link into the chat. There we go. So please check that out following today's session when you get a chance. So with that, I'll hand things off to Ben and Jerome to dive into today's topic. So take it away, guys.
Thank you. Thank you. Don't forget to unmute, Ben.
I'm going to unmute my microphone there. Zoom fail of the day.
You gotta have one.
Yeah. Welcome, everyone. Road to the Metaverse Creator Series. And welcome to our session on how to bring your real-time digital twin data into Unity. So we'll start with a high level and kind of look at the ecosystem of all the different ways you can bring information into Unity. Jerome, you want to kick off with us with Arduino?
Ooh, yes. So we started with providing links to some further resources to connect to your digital twin simulations. Obviously, starting with Arduino, an open source hardware platform vastly used for prototyping, but also for production these days. There's quite an ecosystem of integrator that have Arduino boards for various use cases. And there's two great libraries which you can use. There's quite a few available online, but two of the one I want to flag because I know people that have used them in the past, like Uduino, for example, to connect it directly to an Arduino board, and also the Arduino Bluetooth plugin is available in the asset store. They are commercial plugins, but they're supposed to be good. Check out the reviews always and make sure they are applicable to you. In the middle, we can see Ben actually. Is that
Azure Connect there. This is me with my Azure Connect. We put a list of a bunch of depth cameras here for you. There's the Azure Connect here, which I love and I highly recommend. But there's also more inexpensive cameras like the RealSense. And Jerome and I actually just bought these Oak-D lights. But these depth cameras give you depth data. For example, we put a couple Kajiro things where you can actually take that depth information and you can turn it and feed it into Visual Effects Graph and do real-time visual effects. Or you can do other things with, the depth cameras. You can do real-time hand tracking, real-time body tracking. We included a couple SDKs there. So, check out those GitHub repos.
Yeah, exactly. And Oak-D is also used a lot for simulations and machine learning.
Computer vision and all kinds of great stuff.
So really good platform that just came out and it's quite expensive to get started. I think it's like
$99.
Yeah.
And then you want to go with the MIDI? We got the MIDI one as well. I think the MIDI one we put here, Kajiro built a repo here. It's called Minis. It's a simple library. And you can get one of these guys. They're 20 pounds. It's one of the simplest ways to just start playing with Unity. Hook up an input device, start programming buttons, start programming sliders. You can see one of the demos Kajiro made is real-time Visual Effects Graph Fireworks. And that's one of the simplest ways to get started with, sending and receiving data to Unity. Let's go to...
There's a visual scripting version which is kind of out of date now because it's still using the old Bolt, and I'll aim to try to update that as soon as I can.
And where are you going to aim to update that and share it with us?
In the forums, of course. I'll post a link once I have finished working and updating the project.
Cool. All right.
Next is Digital Twins, IoT, and Geolocation SDK. So again, we try to compile a few resources for you to get started. Azure Digital Twin is a very mature platform. There's also Azure IoT. Both of them are really great. Learn track on their website to get started with that backend platform and Unity. So check the links which are provided. We're going to use Azure Maps or Bing Maps in our demo today.
And then later in our MRTK session, we're going to take a look at those. And there's a lot of, services that Azure provides, which really integrate well with Unity. Some of the stuff I've played with is, speech to text translation and also real-time translation. So you can speak in English and it'll real-time translate to things like German or Mandarin Chinese, which is really fun.
Yeah, it's amazing. For more industrial use case, if you want to connect digital twins, for example, to ROS servers, our Unity Robotics Hub has you covered, supporting both ROS 1 and ROS 2. These are servers that can synchronize data between physical or simulated robots and visualize robots inside Unity, but you can also use them to create training data or synthetic data in order to do simulation and machine learning, for example. But that open source library provides all the tools you need to import your robots using your RDF and also connect them to ROS. And that was used recently on some fancy XR demos, for example, for Microsoft Build that was built with Unity and used this integration to connect to a physical robot in order to visualize it. And then finally, we have mapping. A lot of the digital twin is geolocated, right? These assets or objects or products are in the physical world. They need to be visible on a mapping API, and thankfully most of the major mapping API have direct integrations inside Unity. So that's ArcGIS, for example, from Esri, Bing Maps for Microsoft, Google Maps and Mapbox have direct integration of their mapping. And then third-party solutions like Online Maps v3, which I haven't used personally, but has some really great reviews on the asset store, and it's a really nice library to check out.
Cool. And so now let's get some rest.
I get to relax from now, right?
So there's there's some questions. Can Unity work with this? Can Unity work with that in the chat? This is just a sampling to help you guys get started. We didn't know we're doing this virtually over Zoom. We don't know who has media devices. We don't know who has Azures. So we all know you have an internet connection because you're watching us now. So this session, we're really going to focus on some hands-on demos on working with some REST APIs, which is fun. So what is a REST API? You can see it's a representational state transfer and application programming interface. But really what it is, it's just a way of creating interactions between a client and server. We can send some data over the internet, we can send some data, and then we can receive some data back into Unity. And you can see here, we're going to take a look at a couple today. We put a couple fun examples for you here. But I'm going to pull over here. Jerome, can you see my dad joke webpage?
I can, yeah.
All right. So this is one fun thing we saw today. We'll do a live demo in Unity, but this is icanhasdadjoke.com. And all this does is it gives you a random dad joke. Me and Jerome are both dads, so we like dad jokes. But you can see here, you can see here it has an API, and it gives you little instructions about how to call that API. And we're going to use this one in Unity, but you can see we can send some information, send some stuff, and tell us how we want to receive this data. So it's going to send a dad joke back. We can get it back in HTML. We can get it back in JSON, or what we're going to do today is we're going to get it back in plain text. So we'll show you how to pull this data into Unity. We also have something here on JSON. JSON is something we're going to look at today. It's a really popular interchange format. It stands for JavaScript, object notation. The thing about JSON that's great, it's easy for humans to read and write, and it's super easy for machines to parse and generate. So I'm going to show a quick example here. We can see we're going to take a look at this over here, but I'm going to show this with our other one we sent you, Chuck Norris API. And you see here, we just have a little call here to API Chuck Norris jokes random. And you can see, oh, let me do a refresh. We didn't use this one as the main demo because some of them got a little racy, but you can see here, we call this and we have a JSON. You can see how it's formatted. It's pretty simple to read. We have a little array here. We have things like URL, and you can see we have a value, and it gives us a little random Chuck Norris. So Chuck Norris turned his clock back 25 years last night. I guess I don't get that one. But you can see here, it's just a simple format. It's easy human read. And you can see we're going to look at later this open weather JSON, and we can find things like temp, and we can send it information of like what units we want. Do we want this back? What did we decide this is? Kelvin? We don't know. But you can send information to the server so you can receive it in other words.
Hopefully it's not Celsius.
Kelvin, Celsius, and all that documentation is typically in the API. So always check that API for reading it. So let's just dive straight into Unity right now. And we're going to pick up where we left off last time. We've got our famous Robot Kyle. We've got the Robot Kyle demo that we made last time. And we built this with visual scripting. So there's a lot of great tutorials on how to use REST APIs with Unity, but we really wanted to make this accessible to non-coders today. So Jerome built this amazing, simple thing. We're going to put this in the forums for you guys to use. So I've got Robot Kyle, same as last week. I'm going to disconnect this here for production value, but all I've got here is this simple speech bubble here. This is turned on. Last week we had on mouse over, on click. Turn this on. I'm going to pull my game window over here so you can see this at the same time. And you can see I'm just turning this speech bubble. And if you go here to this text, it's just a Text Mesh Pro object that says, "Hi, I'm Robot Kyle. I like to party." So let's turn this off and let's hit play and see what we get. All right. So now we've got this speech. You can see here, we've got this whole script we're going to look at in a moment. But right now we've got it set up. So if I go here, let's go full screen here. Let's go, I click on this and you can see I'm actually updating this object here with I'm calling that API. And what do you call a pile of cats? A Meowtain. So we get bad dad jokes. So every time I click on this, it's going to call that REST API. It's going to send a little data. It's going to get some text back, and it's going to update this Text Mesh Pro object. So let's take a look at this in its full form, and then we'll jump back in. But let's go here and we'll scroll in, and you can see here, I just have a simple on enable. So when that text bubble turns on, I can call here this web request, icanhas dad joke. And as we said, we're going to send a little information to the server regarding what format we want to receive back. We had options for HTML. We had options for JSON. But because this is plain text, we're just going to get that plain text and use it as it is. And we're going to send that web request. And you can see down here, this is the data it's sending back. So we're going to grab that data, but we're also going to make sure we get that data. And as you can see here, I've got my values turned on. So as this plays, you can see what this is doing. So it's getting that data. It's telling me that the data received, and then I'm getting this data here and it's turning it into a text. And I have this optional part where it's just outputting to the console, just as a best practice. But realistically, every time I click, it's going to send an information to that server, receive that data. It's going to wait for it, and then it's going to go update this Text Mesh Pro object. And you can see this is that object I'm going to update. So I'm going to go ahead and I'm going to connect this part for fun. I'm going to double click back to this. I put a little, like we did last time, just for fun. Just whenever you make something, typically you want to do a couple of things. You always want to play a sound, maybe kind of give some kind of visual update, and maybe trigger an animation. So let's go here so we can scroll out, and when we can see this little flow through, you can see every time I click on it, I'm getting a little dad joke, and it's updating this Text Mesh Pro object. So again, it's just sending a request, receiving that text, and then updating this little thing. Some of these jokes are terrible.
Well, they're dad jokes.
Yeah. Cool.
Lots of anticipation in the chat, Ben. People were asking if Robot Cow was going to say dad jokes, and I think you blew people away. They're amazing.
No, we did the laugh, but maybe when we get to the HoloLens, we can do text-to-speech conversion. But again, Jerome's going to go into this. Like we said, there's lots of stuff on doing this in C# on the internet, but we really want to give you this basic thing and a couple different URLs so you can just send it, see what kind of data you get back, and then what can you do with it. Cool. So I'm going to jump back, and I think, Jerome, this is where you take over and explain the hard maths.
Oh, I might. All right. I'll let you. Yep, we're there. Okay, let's go to grab my share. There we go. Can everyone see my screen?
Yep, but we got your little text bar at the top. You're on present mode.
Yeah, that's good, because I want to be able to jump to those slides anyway. So I figured I'll save myself the trouble. All right, everyone. So as Ben mentioned, there's tons of reference online about how to get web requests inside Unity. Yes, web requests are pretty simple, but actually, when you look at both WebSockets and this type of web request where you request for data, this is really the backbone of most communications when it comes to digital twin and IoT, right? You whether it's with ROS or other protocols, you usually just send a request basically for data or register for an event based API, and then once the event is triggered, you receive some data that lets you handle it in a way inside your application. So it's really, this basic step is what's being done throughout the process, and it's something that you would have to handle the same way as you handle these web requests. You're going to handle more and more complex data sets or various data sets in order to represent them. So I wanted to flag here a couple of things. Let me get my laser pointer in. There we go. A lot of the documentation, and Ben can attest to this, is referencing the www API, which is still inside Unity, but is now obsolete, has been deprecated. So we recommend that you look at the new Unity Web Request API that's available inside Unity, especially 2021.3, the versions that we are using for this series. And this is really all you need to use in order to send and receive data to a web server, right? As Ben highlighted, the data comes inside a download handler, right? But if you are sending data, so custom data, for example, to a server, submitting it, for example, I don't know, sending an image from a user within the application, then you can use the upload handler also to package that data, right? And this is really the minimal C# script which you can use. It's pretty much taken from the documentation, and as you can see, it runs in a coroutine because you don't want to block the main thread, the main execution of your application. You want to request the data and then get a notification once that data is here, and the rest of the application can keep running as normal, right? So you still want it to be interactive to the user. You don't want to block the whole thing. So we usually advise that you use a coroutine or await and sync, for example, async, sorry, and await, which is another way of doing that in C#. But the simplest way is with a coroutine, calling this function, which generates a web request or creates it, right, using a URL. In this case, it's where is the ISS in the world right now or in space right now. And sending this request and have a yield return, which is, this thread is now, or this coroutine is now waiting for this request to finish. So it can finish because it succeeds, but it can also finish because it fails. And so a good practice is to always look at the results of that request, and we'll show you what that is in Visual Scripting. Ben kind of highlighted it a little bit earlier, and check if it's a success. If it's a success, then the text in this case is inside the download handler, and we can log it in order to see what's the results. But if it's an error, we can log the error or handle it as we need to. Okay, so this is the C# way. There's tons of documentation on how to do this with C# if you want to jump into it. Today, we're going to focus on how to get this done with Visual Scripting. So the only annoying part is that there's a little bit of prep work that needs to be done for Visual Script to be aware of Unity web requests. Although they are part of the API, they're not added by default to the nodes which are available in Visual Scripting. So you'll get those slides after this session. They'll be posted on the forum, and you can use this as a template to update your projects immediately after this session, right? Or you can do it, follow along. But you need to, basically in the node library, you need to add those two modules, and I'm going to show you this in a second anyway. Regenerate your nodes, and then in the type options, you need to add minimally those 3 types, right? Although the async operation here is sort of optional, but it is the value returned when you send your web request. And yeah, regenerate the nodes, and now they should be available inside your graph, right? So this is what the graph looks like. As I said before, this is where you architect your web request, you send to the server, you wait for the reply. This is where the error message will be if the return value is erroneous. This is to check if the web request is done. And this is the download handler, which could be actually also another type, like a download texture handler if you are requesting an image, right? And this is where we check that this the results value is equal to success, right? So again, very similar to what Ben showed you. Let's look quickly at this project. So here in this project, which again we'll put on GitHub hopefully next week, and we'll post that on the forums. I have both versions of the minimal REST API script that I just showed you before. I'm not going to dwell on that, but I have the Visual Scripting version here, right? And so let's go to our project settings right quickly and look at the nodes. So this is where you need to add the nodes I mentioned. So here I've added those 3 nodes. I've added the Unity web request module, the Unity WW module, WW module, and then the Unity web request texture module, because with some of the APIs that I was working with, specifically the weather, you can also request a weather icon. So this was for this purpose. In this case, if you're not downloading textures, you don't need it. And to add them, you just click on plus. It's ask you which assembly do you want to add, and if I query for web request, I can see there's a few here that I can add, and I just select the one I want. In this case, they already added, so I don't need to. And then here it might say generate nodes, or if you already generated nodes, it's going to ask you to regenerate nodes, right? But it's the same button. So you click here. The Visual Scripting API is now going to be informed of those 3 modules, which are actually assemblies, right? In C#. And then inside the type options, you can see there's a whole bunch of times that come by default. Usually it ends here with exception. I have added all of these for my work for the various demos that we are doing today. And you can see that I've added the web request type, the web request texture type, the download handler textures. Again, those 2 are sort of optional for textures. Only if you want to download textures from the internet, you need to do so. This is, again, a return value of the node that sends the web request. And then here I have a JSON parser, which comes with Visual Scripting. So it's called the FS, which is full serializer, I believe. JSON parser, so super useful when you get a JSON request. You can use that to parse that request in directly in Visual Scripting without having to do anything outside of in C#, right? So those are the settings. And again, once I have added those, I click generate nodes. And now when I go to my Visual Script, you can see that we have the nodes here, right? Unity get a web request, and send web request, for example, right? All of this is here. And here, this value, I'm exposing this value. If I go here, we can see that this is the web request async operation. So I know it's a bit scary, but that async operation basically wraps the web request that we are just sending, right? So I could get it here. So this gives me this same object, right? And then here I could say, hey, can I see all the values? You can expose a Unity web request, right? And that gives you all of the values that are inside this object. So you can then, figure out like, oh, this is done. I need to check this to make sure that the request is done, etc. And you can see if I do this, it takes me, hey, do you want to hook that up to an if statement, right? So if it's true, if it's false, etc. The same way we have it up there. So rather than do it here, I'm grabbing the value here. It's the same object, right? It doesn't matter. It will be accessed when this completes. So that's a little overview.
Yeah, someone's talking in the chat, asking about like creating custom nodes, and these are all stock nodes. What Jerome showed you is adding those in the project setting. They're just not visible typically, these web requests, so you kind of have to add them. And we put that documentation in the presentation, which we'll post in the forums. Yeah. But for those excited about creating custom nodes, Jerome's going to cover that today.
Yes, we are actually, because we're going to explore so you can see here, Unity gets, right, with URI, right? And Visual Scripting lets you know which one is what. And here is the one that we are using, where I'm literally taking the URL for that API, right, for the ISS location API and dropping it here, right? And then this gets a web request. So web request, the reason why you use this call is because they are literally used once, right? You send a request and you're done with it. You don't recycle them. You don't cache them. You use it once and then it gets disregarded, right? For security reasons. And once it's been sent, it cannot be modified anymore. So it's kind of like a read-only object just for safety, right? So this is why you do like, Unity, you don't create a new web request. You request from the API. You request it from the API. There we go. So that's this, and then I think we dove in already. And now we can go into the next section, right? Any questions so far while I hydrate?
Oh my God, there's tons of questions.
Yeah, let's jump in with a more general one. Because I saw a few of these popping up in the chat as well. Just what is digital twin for Unity? Because they have a feeling that it's a very simplistic approach compared to like an industrial model.
Well, should we give
it is and it isn't, right? There's no hard definition, but digital twin, the idea is to take multiple data sources, so that can be 3D models, but also real-time data APIs, and bring them inside Unity to visualize them, to simulate synthetic data, or to analyze, right, and make decisions. So that's really the core here. The core is to show how easy it is to bring external data sources inside Unity. So we already showed you in previous session how streamlined it is to bring 3D assets inside Unity, how to create behaviors with Visual Scripting, for example, for those assets. And now we're going to show you how to take external data sets like text inputs, for example, or geolocation data for the ISS, or weather data in real time, in order to simulate, the weather conditions at that location inside Unity, right? So that's kind of the idea. It's creating a digital twin of the world, but you need real world data in order to do so.
I just dropped a link in the chat, which is our official Unity What is a Digital Twin page.
Awesome. Thanks, Ben.
All right. Okay. Time check. Yep, we're at 4:30, so let's go. So today we wanted to sort of build on what we did before. So, bringing data inside Unity, 3D data, and then connecting to data sources in order to visualize it in real time on the platform. The link can be shared now on the chat. We have a version of the application that we built, which is on Furious, that you can access right away and see what we are going to walk through and help you build. And obviously we'll share the source code for this on GitHub in the next week or so. So while you explore the application, I'll go through a little bit some of the elements that we've used. So I found a really great vertical wind turbine model by Rifki Zaidani. I hope I'm not butchering his name. This was created in SolidWorks. I imported it inside Unity using Pixis plugin. If you're curious about what that is, go check out our session on getting importing assets inside Unity. We have a little section on Pixis plugin or Pixis Studio. So this was downloaded from GrabCAD. It's free and available on their platform. You just need to sign up in order to get access to the downloads. For the C# side of things, I've used Simple JSON, which is a JSON parser available on GitHub, open source, and it's a really simple one. Unity has its own JSON parser, but it asks you to pre-create the objects that you are going to parse the JSON data into. So it's a bit cumbersome. This basically allows you to query a dictionary or a lookup table with all of the data inside that JSON object without having to necessarily pre-create all of that data inside a C# script. So it's a little bit more convenient, probably less efficient, for massive data-driven applications. But, for the sake of just parsing, for example, the weather data JSON, it's fine. And then finally, the Microsoft Garage project that integrates the Microsoft Bing Map SDK inside Unity is absolutely brilliant. Check it out. Supports obviously XR also, which is really great. And I think, Ben, that was something we were thinking of doing for the next session.
I'm sorry, which was that?
The Bing Maps integration for HoloLens.
Oh, yeah.
All right. So I wanted to start the session with creating the wind turbine, right? And hopefully you're looking at the demo. I'm going to pop it up on screen now, and we're going to press play just to have a quick look. As you can see here, Visual Scripting was extensively used for this demo also. And so the gist of it is we have our little weather API. I can maximize my screen here and switch this to free aspect so it fulfills the screen. So little Cinemachine camera, as we showed you in the session last month, right? That's anchored to my wind turbine here. My wind turbine is sitting on top of this building. It's a bit offset, but I'm actually using the mapping API to position the wind turbine, so it's on top of the building, not inside it. We had a few interesting issues with that before. Let's go to Montreal and update, and you will see we're on top of the hill here. Perfect. We can see that the weather speed has updated, my power output has updated, my weather data has been pulled, and as I mentioned before, we even put a little weather icon that comes from the API, right? So this is all updated in real time. And right now, let's have a look at this weather turbine and how do we get the power output for it. So I have found this brilliant site and I have it open here. Let me unpause it. You can see it's the wind turbine calculator from Omni, and it allows you to enter the values that you want to use, whether it's horizontal or vertical wind turbine, and gives you the power output, before losses. That's the one that I've used because this is just more math, and that's really dependent on the manufacturer data. So I don't have this for this specific wind turbine. So I've just stopped here, which uses the turbine efficiency to calculate the final output from the theoretical wind power. But what's great with this page is if you scroll down, you'll see that not only does it explains how wind turbine work, but also gives you all the formulas that were used to do those calculations. So it makes recreating those in Unity a lot easier. Now, if we go inside my turbine script here, oh, spoiler, we're looking at the on-weather custom event, but we can see that on start, I basically grab some of the values here. I'm going to open up my Blackboard, right? This is where the Visual Scripting variables are. And two of the public variables on that object are the diameter and the height. So this would be, this diameter and the height of this wind turbine. This is what you need for most wind turbine, but it's depending on the type, it affects greatly the production of power. But in this case, we have to calculate a sweep area where we just multiply the diameter by the height. And then I have a little sequence here. So this is calculated on start because theoretically it shouldn't change throughout the application. And then here I do like 3 separate calculations. The first one is I calculate the theoretical wind power using the air density. Then I calculate the output, which is that theoretical wind power multiplied by the efficiency. So in this example, if we go to the variable, the private variable that I have on the graph, you can see it's 40%, 0.4. And then I set that as a scene variable. So we can go to the scene tab here so that other objects can find it easily. You can reference this scene variable from anywhere in the scene inside your Visual Scripts to make it easy to share that information. This is one way of doing it. There are others, but it's quite convenient. Then here I'm doing, using the wind power again, I'm calculating the rotation per minute for this wind turbine. So again, that's all from the website from Omni. And finally, I take that RPM and I convert it into a rotation per frame, right? Using time that the delta time to get this per second to per frame. So that's the idea here. And then there's a little magic number here, which is the tip speed ratio that's going to be dependent on the type of wind turbine. So I have 3 here because it looks cool. By default, it was 6 in the calculation, but that just rotates too fast. So that rotation, although it is realistic, is actually not real. It's a bit slower than what it should be. But yeah, so this is how I took, just using visual scripting, this series of formulas and apply them to my model. What's great here is you can use the values that you have inside your Visual Scripts, go to the web page, input them and make sure that you get accurate information, which I did. And it wasn't obvious at the beginning. There was some mistakes. There's a lot of little math calculations which need to be inputted. So it's time consuming, but again, it's something that you would have to do anyway in order to calculate this. So obviously the wind power here, I can change it manually, the wind speed, but the idea is to connect it to a real-time weather data API, right? So if I look for the wind currently in Montreal, I want this to be realistic. So I need to grab this. And this is why we decided to use the weather data, right? So again, as Ben showed you, it's a REST API. You send a request for weather data, mostly passing the location and an app ID. And then the API will send you the real-time, the current weather data at that location if it's available. So for this, we used Open Weather. There's a ton of services out there that you can use. This is just one of them. You need to sign up for it in order to get access, and you need to create an API key. This is most REST APIs will require you to have a developer account and then request, create an app ID, for example, for your application, and then pass that because they have commercial tiers. The free tier here, I think, is 1 million requests a month. So for, side projects, it should be fine. But obviously, if you do an application that's, widely successful, then you may need to pay for your request. But this is where you input this. You can see here that you need to form that URL. You need to create the request with that URL that includes, for example, the latitude and longitude of the location you want the weather for, and your application ID, which you created on your account with Open Weather, right? You can also query by city name, which is what we're doing here. Rather than entering latitude, longitude, I'm calling the city name, and hopefully there's a city that's being tracked with that name. And then this JSON structure is pretty simple. Ben showed you before in his little demo, what it looked like, in the JSON slide. So we mentioned that this was a hybrid workflow. So although I do have a version of this pulling the data directly from Visual Scripting, in this case, I wanted to showcase what someone already asked about, is creating custom nodes, right? And one of the best custom nodes you can create is an event node. And this is what this is. This is a custom event node, which I created using C# that extends the event units from Visual Scripting and provides a way of getting notified of the weather data update inside any visual scripts that require it. And in this case, I'm getting notified to grab the wind speed. That's all I care about. I want to get that wind speed at this location and update my calculations accordingly, right? Again, my digital twin being able to visualize real world data using that. So this event comes from my Open Weather Data Manager. This is a simple C# class, very similar to what you saw before. It's a little bit more complex because there's a few more options. But this weather, basically, this class just connects to the Open Weather API, either automatically on start or manually when I click update, and pulls the weather data and then notifies everyone, right, of that data. So I can quickly show you, don't be scared, we're going to jump into C# here. Let me hide the Explorer and maybe expand this side. I have two sides here. This is the Open Weather Data Manager. So that's this script here, right? You can see that I have a couple of events name. One is update city event name, which this manager listens to. So that's when the application will request, hey, can you update the weather with that city? And then this manager will do so. And the on weather update event is basically when the weather data has been updated for a specific location, then send that event to the rest of the application. The rest, again, I have here because you can query the API two ways. So I have, whether you're querying by city name or by latitude, longitude. So this is a bit of boiler, plate code, which is not necessarily super interesting. Whether I hold the city name, the latitude, longitude. This is fetch on start, which tells the application or tells the manager to, as soon as the application starts, get the weather data. That's an option that I added, right, for convenience. And then, as I say, this is a singleton. So if you don't know about this type of classes, it's basically an instance of a class which is unique. So when you call Open Weather Data Manager, that instance, it returns this game object, the game object that this is attached to. This is the instance that's in my application or in my scene, just to make it convenient and easy to find for other objects within the application. And here on start, you can see if fetch on start is true, we call the coroutine to fetch the weather data. That's as I mentioned, a cool routine. The same, it's just a bit longer because there's more functionality in it than in the simple example I showed you earlier, but it's the same exact thing. We basically, here we assemble a URL based on the fact that, do we want to query by latitude, longitude, or do we want to query by city name that impacts the data that we're sending to the server through the URL composition. And then we just get our web request, wait for the return, check for the results again. And if it's success, well, we update our weather data. Okay, so update weather data is just a simple function that takes the raw text that came from the download handler. And then, as I mentioned before, I'm using simple JSON to parse this. And here you can see I parse it into an object called weather JSON. And then as like Ben said, I debug log weather JSON just to make sure that I'm getting the right data, but also to usually figure out, hey, what's the data format that I'm getting, making sure it's as I expect. And then here I look up, right? So the weather, I look up inside the coordinate object as a latitude and a longitude. Inside the weather object, this is actually an array. So it's a list of objects. I grab the first instance in that list and I grab the description. The ID, which is something that we added later with Ben, actually. I didn't have this originally, but he needed it for one of his demos. And then here I got more data for main. I'm getting the temperature, the mean, the max, for example, et cetera, et cetera. So you can see here, again, this is not simple, but it's done. So you'll get it with the source code. You don't have to redo it. You can explore what it does or customize it, for your own use cases. And here at the end of the class, I have another class. It's not really best practice, but it's convenient to have it all in one file. And that's the Open Weather Data object, which kind of holds all of that data that's been pulled from the server, or the one that I want to handle inside the application. So you can see here the values, right? These are variables. And then this is what's going to be sent by these two things here, which one of them is for C# land. So any C# object that want to listen to that event will register or subscribe to this action. This is a Unity action, and get this weather data. So the open weather data object. And then the event bus is the fun bus. It's the visual scripting event system. So that event bus, I'm asking it to trigger a new event, which is this name. So that's the name of the event, and with this value, which is the latest weather data value. And if you have been picking on the right side, you can see that my custom unit here is an event unit that handles this type of event, the open weather data event, the same one as here, right? And then when I've set up here all of these values. So this is those values that come in, including the wind speed, for example. And basically, when the event is called, this function gets called automatically on all the event nodes that handle this type of event. The values are updated, and then this flow here is called. So now I know that, I've received all of that data. I can then handle it in Visual Scripting. So again, you can do it all in Visual Scripting. You can do it all in C#. That's not the question. But those type of hybrid workflows are really great for handling complexity, like, connecting to a backend service inside C# where a developer, can create it, and then bubbling that up conveniently to anyone that doesn't necessarily use C# but wants to use Visual Scripting, and making it easy to create. And if you want to see how easy it is to add, is now that I have my custom node, I can just enter weather, and you can see here I have my own weather data event. I grab it, and now every time the weather is updated, I can do something with it. So that's as simple as that. So it's super convenient, and Ben used that actually to do his own custom demo. Right?
Yes.
Okay.
Yeah, and I think one thing to say is, again, check the API. Like Jerome said, I needed some custom data that he didn't have in his node, and there's a ton of information in there. So you can go dig through that API documentation. And there's things like we grab the icons and we grab the images, which Jerome will show you here, but you can grab sounds, you can grab images. I used it to grab descriptions to do like a 3D visualization of weather.
Got it. So here, if I go, and let's go back to London. Although London is a bit lame because there's no.
Let's go Chicago, the windy city.
That's right. So you can see here, this has been called now, and the value here has been passed, right? It's 412, right? So Chicago. Yeah, Chicago usually has good wind. Let's hope today. Let's see. Yes, we have 5. It's okay. So you can see again the data here, the event. As soon as I click update, the weather manager, the open weather manager queries for weather data. And then once it receives the data, it sends the event, hey, I have new data, update yourself if you want to. And all the objects that are listening to this are able to grab the latest data and handle it, right? And that includes this dashboard, for example, or these objects here, right? So we're going to look at this also at the end. It's how do we kind of like bring it all together inside the application. So we only have a few minutes left in official time. So I want to go through this. Again, we're going to share this with you, including this custom node, and we can go over in overtime if you want on the anatomy of custom nodes. We're going to share a lot more of these with you as we move into XR. We're already working in creating custom libraries, for example, for the XR interaction toolkit, so you can handle those events inside Visual Scripting. Actually, those are already online, but I haven't published them yet, but I will share them on the forums once we get to those episodes. And now just to cover creating the dashboard. So again, this is a bit rinse and repeat, not much new here, but it's how do, adding interactivity. So, creating a text field and then the button to send the data to the API and get the results, displaying the weather data, displaying the system information when it comes to the wind turbine, and adding context with the 3D map API. You can see it all on Furious, as we said before. Maybe we can pop the link again if you missed it, and you can go play with this as we go through this. So you can see here, just like Ben was showing before, I have a screen space UI. I can focus on it and zoom in. There we go. You can see this is the UI. There's a TextMesh Pro text field in there, which takes the input, and a simple button. I'm going to open it up here so you can see the button, the input field, and then our weather widget, right? And that weather widget, as you can see, has its own visual script, right? So this is its own object. And all it does is when the weather data is updated, it gets notified by this event, right? That's why event bus are super useful, because you don't have to recreate all of this inside the node. All you care about is the data, really. So that data comes through, and then you can handle it. You can update the weather description. So this is just as before with Robot Kyle and Dad Jokes. We set a text field. I'm not going to dwell on that too much. Here we round some values because it's temperature. It's a float, and you don't want to say it's 12 degrees 0.56. Most people will expect you to give them back 13 degrees. So, round the value either up or down. And we convert that to string, so we can do manipulations there. We add, for example, based on the temperature unit. So this is, for example, a custom node which I added because you don't know whether we're querying in Fahrenheit, Celsius, or Kelvin. So you'll get a custom unit here that matches whatever the request was, right? Here again, we update the city name, and here we grab the texture which came back from the API and assign it to our raw texture. So this texture here, right? This is how we build this together. And similarly, if I go to my dashboard here, so this is the little 3D dashboard, we can see that the wind speed data, it showed at the top here, the in meter per second. This comes directly from the weather data API, versus the power output is being queried using this really cool node, which I thought Ben showed me, but then he said he didn't, which is called cooldown. So this is really convenient. Is you want to update something frequently, but you don't want to do it on every frame, right? So you put a cooldown node, and basically it tells Visual Scripting and Unity, wait 3 seconds, then update this, right? So it's going to update it every 3 seconds versus 30, 60 times per frame. So that's a really easy way to do this. I like this a lot because the power output is calculated once the weather data is received. So we need to wait a little bit for that data to be available, to be updated. So, I poll it every 3 seconds just in case, right? So it's kind of a hack workaround, but it works. And then, that's it. Then we set the text field here to reflect that value. And that's as simple as that. I think that was the few things that I wanted to show. There's one last trick which I did, and we showed you before Montreal, which was great. Originally, my wind turbine was in the ground because this is really high, like the elevation is quite high. So the wind turbine was basically inside the ground, which didn't look great. And I wasn't sure what was the best way of doing this. But the brilliant map API from Microsoft had already a little function which is super useful. It's called a map pin. So there is a pin here which is at the base of the wind turbine. You might not see it, but if I go into the scene view, you can see this sphere here is basically a standard map pin, just that you would have to showcase a specific location. And this gets updated to match the elevation of the map automatically by the Bing Map API. So I have this hidden pin, and every time I update the Big Maps API, this this pin also is updated, and then it allows me to reposition my wind turbine to be at the top of the map, so it won't be inside the ground, right? So again, very useful little hack here to know exactly where to position 3D objects on the map when they're not necessarily pins, right? Because this is a bit more complex than just a location pin. And yeah, this, if you add the correct objects to Visual Scripting, you can do it in Visual Scripting. Here, for sake of speed, I did a little C# script. We can go over that in overtime if need be. So I think that was it for me. We have the try it. I hope everyone tried it already and have fun with it. And yeah, so more stuff to come. We're going to keep building demos. We're going to keep creating content. Once we share that with you guys, please share on social media, all of that stuff with us, whatever you create, but also in the forums if you have questions, etc.
Yeah, and Jerome has made that weather for you, so you can go sign up, make your own API, and make your own weather apps. So we'd love to see what you guys do.
Actually,
take the temperature, try different data points, and see what you can do. We keep talking about doing like data visualization with color and temperature and whatnot.
Yeah, so in overtime, I'll show you how to do a custom UI for this, because I already made it. But here we decided to show you that this is the default way Unity shows the information on this class. And you can see there's an API setting here. So this is called a scriptable object. It's kind of like a rich object in Unity. So it's a class that a code that you create. Then you can instantiate these objects, right? These custom objects in order to do things like settings. So if you look at the URP setting, for example, asset that you create when you want to tweak your rendering settings, this is a scriptable object. So this is a custom one. And here you can see I have my app ID, which you should use your own. I'll probably disable this one after the webinar anyway, so that the whole internet doesn't use that to query all kind of location data. But I also have, the base URL for the API. There might be different version. I'm using version 2.5 here, and also the base icon URL to retrieve images and the units that I want, right? The good thing here is you can have one object, for example, for the webinar today, or for development, and then you can just duplicate this and have a version with a different app ID, which is for your customer, or for your live application, which uses a separate app ID for tracking. So that's why I have this here as this setup, and then we'll show you a nice little custom UI for the Open Weather Manager afterwards. And then back to the slide. I guess back to Drew and Q&A.
Okay, perfect. Let me just grab your screen once again. All right, yeah, so we'll answer a few questions up until the end of the hour. Then we'll do our official sign-off just at the end of the hour, and then back to Q&A in overtime, if that's all right for everyone. Let me just get the video panel back. All right, first question then. XR, VR, MR, Metaverse. Isn't there just one term we could use to define them all?
No. It's a spectrum between fully virtual, like VR, where you don't see any of the physical world, and fully immersed inside the physical world, where you just overlay a little bit of information on top of it. So there's really, like, XR is, I guess, as close as you get for VR and AR, but Metaverse also goes beyond just head-mounted displays, right? It's sensors, it's local compute, it's embedded computers, etc. So there's a lot more there.
Sure. Okay, next up here, since you brought it into Arduino, I want to ask, what shield and components do you recommend to use or to get them?
Ooh, I use an Arduino Uno. The shield and the components depend on what you're trying to do, right? If it's an autonomous robot or just a weather sensor, it's vastly different. But Adafruit, or what's the one in the UK? I can't remember now. Has tons of shields. Yeah. So there's no one answer here.
Sure. Just a reminder, I see a lot flowing into the chat right now. If anyone has any questions, please type them into the Q&A pod. We might just lose them in the chat here with everyone kind of signing off and saying goodbye. So yeah, just pop them into the question and answer section there. Okay, next, does Unity have connectivity to Omniverse or just Azure? Pardon.
Oh, there's connectivity to pretty much everything with Unity. Omniverse relies a lot on USD, and there is input-output of USD with Unity, so shouldn't be necessarily a problem.
Right. Okay, so towards the beginning of the session, we were mentioning IoT. So can you create your IoT device with Arduino to interface with Unity?
Yes. Well, Internet of Things means it's connected, right? So it's accessible via the internet. You can connect directly to an Arduino from Unity through the USB port or serial bus using some of the plugins that we mentioned before or the open source versions, for example. But the idea of IoT is that Arduino sends that data somewhere on the internet, and then you retrieve it from your digital twin application, right? So you're not connecting directly to the device, but you're accessing its data. So both are valid, and available with Unity, right?
All right, awesome. So we are going to continue with questions in a moment, but just for everyone who has to sign off at the end of the hour, and because we have reached our technically official end time, thanks to everyone for joining us for today's session. Keep an eye out for a follow-up email containing links to resources mentioned in today's talk. And please check out the forums as well for additional resources. One more reminder before, if anyone is dropping off now, to please check out this survey I've just posted in the chat at the QR code here. We really want to learn from you about how we can improve our presentation, so please fill that out when you get a chance. And for everyone who has to drop out now, we'll see you next month for our next session of the Road to the Metaverse Creator Series. But with that, we'll go back to Q&A. And our next question here is asking for the project files. Are they on GitHub?
There will be, yes. They're not today, but we'll share as much as possible on GitHub.
We got to strip out all the stuff we can't share. We can use it, but we can't give it away for free.
Actually, this go around, Ben, everything we use is either free or available online, so I think we should be safe. But yes.
Yeah. Even my little robot Kyle laughing.
All right.
Awesome. Okay. Would you consider projects for Unity with motion body sensors?
Yes. OGD has a great body tracking. The Azure Connect also can do body tracking.
Your ARKit can do body tracking.
Oh, correct. Yes. Even better. Yeah. So 100%. Yeah, there should be libraries or SDKs or demos for all of those, right?
Yeah, a great one. I think in Microsoft, what is their event? Microsoft Build, like last year, they had an Azure DK to Unity body tracking presentation, and the files are online. It's really great.
Yeah, I tested it. It's actually really good. Yeah.
Excellent. Okay, next up, do you have an example of a digital twin using MQTT communication?
No, I don't have out of the box an example, but there are a few libraries to get MQTT events or communication. It's just another protocol for everyone interested. So yes, it's available for Unity. I'll check if there are. If you have a specific one that you're looking at, just post it on the forum for us to have a look, right? And we'll keep the conversation there and see if we can find suitable solutions in the community resources.
All right, perfect. Okay, next up, are there any tutorial projects I can study for myself to make an AR controller for real-world units?
What is going to be more specific on that one? AR.
Yeah, maybe if
DMAS can control through AR for some physical device, robotics or something.
Anything real world units. I mean, if you can hook it to Unity, you can hook it to something in AR.
Yeah. Actually, yeah, one of my colleagues, Daniel Bierwith on the solution engineering team, was showing me a good project like this where they mapped real life data to a digital twin of a little autonomous robot that was avoiding obstacles. And that was all connected through, it was an AR, but it was like a similar view, but that was all connected with ROS, right? So the Robotic OS server. So yeah, it's definitely doable. You should be able to. It's just the challenge is to correctly position the content, right? So the AR content be positioned exactly where the robot is, for example, if that's what you're trying to do.
Right. And would any of that content be available in like the form of a tutorial online, or do we have any access to
Not that I know of, no.
Okay.
Yeah, post in the forums and see if the community has something they know of that they can share. Forums.
Good point.
All right, next up, really enjoying the series. Thank you. I was hoping if you have any advice, tutorials, or documentation in regards to optimizing and utilizing Matterport digital twins into Unity. I've used Vuforia's area target generator to do so, but wondering if there's another way. Cheers.
Oh, I haven't used that, the Matterport digital twin, so I don't know what that is. Sorry. Yeah, post in the forums, either the general Unity forums or Road to Metaverse, and then we'll try to get that looked at or to figure it out.
All right, excellent. Thanks everyone for your questions. Love to see all these questions rolling in. Can Visual Script run with only game object? Is it possible to write a full program using Visual Script without representation into the Unity scene?
A script machine needs to be attached to, a script graph needs to be attached to a game object. So you cannot do like what I did with the Open Weather Data Manager, which is, a singleton. You cannot do that from a script, right? From a Visual Script, sorry. It's really baked inside. It runs inside and attached to a game object.
Excellent. All right. Do you guys have any courses related to Scriptgraph within Unity?
Yes, we have a great session, Ben, right? Last month.
on Visual Scripting or?
Yeah, our live learn session. There's some good, really good also learn content, right, with Visual Scripting. It's geared towards game, but it's really relevant. But last session was all about adding interactivity, which is using Visual Scripting. And then last month, also, we had, or 2 months ago, we had a session on specifically a live learn session on Visual Scripting. So you can go there and check that out. And then on our forum, there's a thread for this session. If you have questions, just post there.
Excellent. Okay, is there an existing module to analyze and make a forecast based on historical inputs?
Not out of the box. You'll have to do your own. But the weather data that I'm querying right now is the simplest form. It's the current weather data. You can also ask for historical data, right? And I believe you can ask for range data. So give me data points for the past month, for example, or the past year. So the API, some APIs will give you also historical data. Otherwise, you need to save that somewhere for yourself and then write some smart algorithms that are going to analyze it.
Yeah, for sure. Okay, what about using LiDAR for surface data?
Yeah, we did a session on bringing your digital physical models in, and I made a LiDAR asset of the Unity London office.
Yeah, this was great. You can also use Pixies to convert your point cloud data into a mesh if you want to simplify things or generate that. So there's I think I did a session last year where I showed how to generate meshes with the Pixies plugin, or Pixies Studio. But so if you want to either check out that session or ping us in the forum, and we can provide you resources for using point clouds in Unity.
Excellent. Hey, can you demonstrate how to control robotic arms using AR, please?
We're going to have to expense a robotic arm.
Yeah. Microsoft Build this year had a great demo. I don't know if it's online yet. I know the guy that worked on it, so maybe I can ask him, but I'm not making any promises. Cut that. Yeah, they have a HoloLens demo where they control a robotic arm from a Unity application to the physical world, and it's connected using ROS, right? They actually use the robotic hubs, which we mentioned earlier in the presentation. So you'll see this in the slide. It's a project on GitHub from the Unity robotics and simulation team.
All right, I would add to that we also have a similar demo setup in our Calgary office. Unfortunately, I don't have access to that robotic arm and demo setup right now. But
can you ship it to us next time?
I'll see. I'll get in touch with some of our Calgary people. All right. What have you done with Azure IoT?
Ooh, that's a good point. I haven't used Azure IoT yet.
No, I've used the Azure services through the HoloLens a lot, but
Yeah.
I don't have any Internet of Things out there.
I know.
So that's why we did the REST API today as a demo, so we're all on the same thing, that we can all have like a unique thing of sending and receiving data.
Yeah. And the Azure IoT, the main thing is that it kind of obfuscate all those backend calls, right? But it's same difference. Some of them might be through sockets because they're more efficient, or to query data in real time. Others may be registered, so you get notified when the data change on the server. So
if any of you have an IoT device that you're willing to share the data with, stick it in the forums, and we'll get funky with your refrigerator in Unity.
Make it read only, so it's safe.
We'll make ice all night long.
All right. Next here we have, can we import data from live surveillance cameras?
Yes, there's a webcam API, and there's a few also commercial assets that you can do, that you can use to get efficient streaming data inside Unity. And then you can do computer vision. There's actually a really good plugin on the Asset Store for OpenCV, and the Ocdi library, which is mostly open source, is available on GitHub, and that has also a lot of really good feed from, detection using OpenCV and things like that, computer vision, to analyze the video feed from the camera. So you can, use that on any kind of video feed depending on what you're doing.
Perfect. So, any recommendations for being able to navigate multiple twins that are geographically diverse using a globe representation, such as big maps for Unity, OpenMap, or something else like that?
Yeah, the same way we showed you before. It's not a globe; it's a localized map. But you could do a hybrid version where you have the Earth. You just transition to that scene, fly to the location, and then at some point zoom into a specific mapping API, right? Just for the precision. So not like the same way we showed you today. Like it's
and I was telling Jerome, I saw one in the Magic Leap, which was not a digital twin, but it was using the Open Air Traffic Control API, so you could track all the planes globally. So you could, say, I want to see this plane, and the globe would go right to the location and the map, just like we had today, and where that plane was, what the elevation was, how long it's been in the air, and all that data that was open to share. So yeah, you can have objects all over the world. I want to make a PS5 Finder API, and they do have PS5 stock APIs. I want to make a global visualization of available PS5s in the world. If anyone does that, share it in the forums.
Geolocate it so you can go there and
there's an API, like, was it Open Stock Finder or something, and you can find all the PS5s and all the different.
Let's check it out.
There's lots of fun stuff to do. Amazon has an API too. Cool.
All right. Okay. More broad question here. How can you leverage digital twins and VPS?
VPS, there's multiple
visual positioning system. Yeah, there's different partners. Obviously, what is it? Niantic has their VPS that's open, that's built upon Unity. There's lots of different people who are doing things with visual positioning systems. And we get back to metaverse. It's all about like creating persistent content in the world and sharing that content with others. And for visual positioning system, it's basically just, Jerome, you went to that. Remember we went to that London user group with that company? What was that called? And then Magic Leap bought them right after, but that was a visual positioning system based out of London. But it's basically taking a more advanced version of Google Maps and taking pictures all over the world. And then, instead of GPS, finding out where you are in the world based upon images.
Yeah, Kijiro has a great library called April Tag too, which are like custom QR codes, but super efficient and multi marker supported. It's really cool actually, because I think it's an open source project, April Tag, and that allows you to sort of with a camera feed to position precisely content on top of that QR code. So it's used a lot actually in robotics simulations to figure out where the robots are within a space. So it's the main challenge is not necessarily that localizing the object, is the coordinates, right, between the virtual world and the physical world, and how do you calibrate that. So that's why Microsoft at their Azure Precise Anchor, for example, that allow you to within a space, precisely locate objects and represent that in Unity. So there's quite a few ways of doing so.
For sure. Okay, it looks like we got 2 questions left here. Do you support Red live updated point cloud streaming data, not post-process mesh?
Well,
I mean, the death camera stuff gets turned into a point cloud before the visualization, right?
Well, actually, it's come as a texture.
It comes as a depth, right?
It comes as a 2D texture. So yeah, you can do mesh streaming inside Unity. There's actually a few open source projects. So you can feed dynamic mesh data to a mesh object, including a point cloud, because the point cloud, if I remember correctly, is kind of like a mesh object, but doesn't have a mesh. It's just a series of points, right? So yeah, you should be able to do so either out of the box or with some custom code. There's Kijiro has a few examples of parsing point clouds open source. Otherwise, there's tons of libraries that can do so at runtime. If you can do it at runtime, you can do it in real time, right?
I love the answer to all this is go to Kijiro's GitHub.
Yeah, of course, Kijiro has done it, right? We're just here to point you to Kijiro repositories. That's our job now.
All right. So our next audience member here is asking, we're interested in building a holistic digital twin of our business operations, ranging from supply chain to manufacture to operational usage of equipment. Most twins we've seen have been around single entities. Any examples we might want to look at that encompass multiple entities?
Yeah, we're doing that digital twin you showed, right, for the virtual ports is definitely multi-entities and facilities. We're also working with
Vancouver Airport.
Yeah, Vancouver Airport to simulate, complex systems. So that's the beauty of Unity, is you can bring in all of those data sets, in right time whenever they're required for visualization or action, and visualize them inside Unity. Reach out to myself, Ben or Drew directly. You have our details, and we'll be happy to put you in touch with various teams within Unity that can help you get there or guide you when it comes to creating those really complex digital twins, right?
For sure. And for just kind of a broad look at a few different examples and use cases, I just posted the Metaverse Minute blog link in the chat as well. So there's a number of different stories there, very specific use cases, digital twins from all sorts of different industries. Exactly. Might be a good place to take a look just to kind of prime your imagination.
The main driver for adoption of Unity in that space is the fact that you can use pretty much any data set and bring that into Unity. We're not forcing you into a specific proprietary format, right? So you bring all that data inside the editor or inside the runtime, depending on what you're doing, and then you can action it or handle it as you see fit. Right? So that's the beauty. But yeah, multiple objects, all of this can be aggregated inside a Unity runtime for visualization or simulation or whatever you want to do.
Right, for sure. All right, last question here for now. Do you know of any projects used Unity with an embedded AI edge device like Jetson Xavier, embedded AI and edge computing?
I've seen demos where they use Unity. I know Jetson is also used for HMI, just as a rendering engine, not necessarily in the AI space. But when it comes to robotics, etc., you might not connect directly to the robot, but if you have ROS as a server, you can kind of connect the two with a Unity simulation or Unity runtime application and your live robotic data from the Jetson board. I'm pretty sure the NVIDIA website has some tutorials or demos using Unity. Post in the forum, and we'll try to dig that up for you. yeah, it's definitely something that we are working with. All of those embedded boards. Obviously, multi-platform is our creed, something that we want to develop. So we work with all the hardware vendors, to make sure that there is kind of like connections, not necessarily Unity running on boards, but that the data can be accessed through Unity.
All right, thanks a lot, Jerome. And that'll bring us to the end of Q&A. So I'd like to thank everyone for joining us for today's session. Unfortunately, we won't have time for overtime this session, but a big thank you goes up to Ben and Jerome, as well as all of our organizers as well. Please keep an eye out for a follow-up email containing links to resources mentioned in today's talk. And one more reminder to please fill out your live session survey as well when you get the chance. This QR code on screen will not work for the on-demand version of the survey, unfortunately. But all right, with that, we'll see you next month for our next session of the Road to the Metaverse Creator Series. Take care, everyone.